Now, so far we have dealt with many problems on differentiation rules. However, we have not covered this notation here. So remember now I believe at this point in time, if you've watched my previous videos, you now know what is this. This is the derivative of f, right? You now know this, how to represent the derivative of f given the function of f in this form. You know that this is how to if I have m, this is the derivative of this function, which is m of x, right? Then you know this one here would be the derivative of this function of Px. Okay, by now you must know that. Then you must know if I have a function y is equals to something, the derivative would be dy over dx if the variable here is x, right? It can be dy over dp if the variable is p and the likes. Okay, but now we have to talk about this one here. When do we use it, right? It's not different from what we were doing. Okay, it's not different from what we were doing. However, I'd like us to revisit the ones we did before, just so that we can see the difference between this one and those ones. Okay, I'm gonna take a problem here, right? Look at this question here. It gave you y is equals to something, and then it says that find dy over dx, right? Remember, what is the first thing we do when you get a question like this? You want to make sure that it's in the form a x to the power n, right? Meaning you must have something here, then have an exponent. Okay, so that is firstly what we're gonna do on this one here. So we say we're gonna simplify. So here we're gonna first simplify this one. Remember, it's a radical sign, so we're gonna have x, then the exponent of x will be on top, then whatever is here would be the denominator. Okay, then what about here? You're gonna have -5, then you say times. Here the exponent was 1, isn't it? It had an exponent of +1 there, right? So remember, when it becomes a numerator, the exponent would be -1. Okay, what about this one? It's fine, we can still write it as half pi. That is okay. So now here we have simplified it. Now it's in this form, right? Now we can just remember we're simplifying. Now we can apply the rules, right? When you apply the rules, we're gonna say dy over dx would be equal to the number that is here, which is 1, right? So we're gonna say 1 times 3 over 2, then we say x 3 over 2 minus 1, right? Then what about here? You're gonna say this number times the exponent, right? So you're gonna say -5 times -1, and then you say x to the power of -1 minus 1. Okay, remember you always subtract 1 from the exponent. Now what about this one here? It's pi, it's a number, so it's just a constant. Remember, the derivative of a constant is 0. So remember, when I'm applying the rules, I write dy over dx, then I simplify my dy over dx, right, to say now the answer would be 3 over 2x. What is 3 over 2 minus 1? That will be half. Okay, and then here -5 times -1, that is 5, and then you have x to the power of -2. Now remember, if they want you to express it in the form of positive exponents, you're gonna say I have 3 over 2x to the power of half, and then I have plus 5, then you're gonna make it a denominator, and then it will have a positive exponent. Okay, that is how we were solving those questions there, right? Now if we do not want to use this notation for dy over dx, this is what you must know. Okay, it then depends on the question. To say the question would say maybe find what, but I just need you to know that that notation, that dx there, it's very much the same as other notations, just that instead of having y is equals to something, you would be having this. Okay, you would be having dx x, and then in brackets you would be having x to the power of okay, in fact let me write it as the one on top, x cubed, then we have a square root there, then we have minus 5 over x, and then plus half pi. Okay, so in terms of this one now, it says your function, instead of saying y is equals to something, that y is equals to something, this part here, this part would be represented by this part here, dx. Okay, that is that's the only difference between these things, but the working out is the same. So it's more of like when you have lim. Do you still remember when we were doing, when you had lim and then you had f of x and stuff, plus h, and then this? You remember when you had this, right? All the time, remember when you were simplifying, you used to write lim h to the power h approach 0. Remember this. So this is the same as this now. Okay, so it's not like exactly the same, but the way of always writing this thing is the same way we're always gonna write dx. So you have your expression inside the bracket. If it's not in the form of a x to the power n, what do? You simplify in that bracket. So you're gonna say dx, and then you're gonna open that, then you say here it will be x to the power 3 over 2. What about here? It will be negative 5 times x to the power negative 1, and then that will be half pi. Okay, just as we simplified it, just as we simplified it here, we are also simplifying it here. However, we write dx. So here we're writing y is equals to, here we write dx. Now, when I was applying the rules, when we started to apply the rules, we now wrote dy over dx. So for this one, when we start applying the rules, okay, when you start applying the rules, you're just gonna write an equal sign. Then you just have to apply the rules. So it means when you apply the rule there, that will be, there's 1 here, right? You're gonna say 1 times 3 over 2, and then x 3 over 2 minus 1. Then you say minus 5 times negative 1, x negative 1 minus 1. Then remember the derivative of that other one is 0. The derivative of this part is 0 because it's a constant. So your final answer will be 3 over 2 x to the power of half, right? And then plus 5 x to the power negative 2, which is exactly the same thing as this one. So the working out is not different, just the way of writing is different. Okay, so now the final answer would be 3 over 2 x to the power half plus 5 all over x to the power 2. Alright, so which is exactly this. Alright, those things are the same, just that here we don't write anything, but here we write dy over dx. Alright, so just remember, when you are simplifying, you always write dx. Then when you are applying the rules, you don't write anything. Whereas here, when you are simplifying, you write y is equals to something, or prx is equals to something, or frx is equals to something. When you start applying the rules, now you're gonna write dy over dx, or dx over da, or dy over da, or p prime x, or f prime x, or g prime x. Okay, so that is how different these two things are. Okay, so let's have some more examples and see how we apply that. Okay, so let's have the second example here. It says find this, determine that, right? It's just gonna give you this as a determine, right? So this is how you're gonna solve it. You're gonna say is it inside here, do we have it in the form of ax to the power n? Well, no, not yet. So we need to simplify inside. So I'm gonna write it as it is, right? I'm gonna write it as it is, like this. Okay, then I have 3x minus 7. Okay, then I'm gonna start simplifying. I write my dx, then I simplify inside. So I say x times 3x, that will be 3x squared, then x times negative 7, that will be negative 7x, 1 times 3x, that will be 3x, and then 1 times negative 7, that will be negative 7 there. Then I write my dx. Remember, I'm simplifying. I have not applied the rules. So I have 3x squared, and then this and that, they are like terms, right? So negative 7 plus 3 will be negative 4, and then x, and then minus 7 there. Okay, then now that it's in this form, right, now we can apply the rules. That's when I just write equal sign, and then I say 3 multiplied by the exponent, right, which is 2, and then I write x, and then I say exponent minus 1. Then for this one, the rule says if the exponent is 1, you're just going to take the number in front, so it's going to be negative 4. Then what about this one here? It's a constant, right? So the derivative of a constant is just 0. So the final answer will be 6x minus 4. Okay, so that would be it there. All right, that would be it. Just remember here, when I'm writing this, I'm just simplifying. I'm simplifying the derivative itself. Okay, I'm simplifying the derivative, because a common error that students make would be to say this one is a constant, then they write 0 here. No, you have already applied the rules here, so you are done. You are literally done. Just that here we are just writing out it in a simplest form. Okay, there's no need to apply the rule again, because to get this negative 4, you apply the rule. Okay, right, so that is what we have there. The next one is this one here, right? So we can give it a try, right, and then see the solution afterwards. Now I'm gonna do it as I was doing before. When I'm simplifying, I'm gonna write dx, right, in yellow, right? So now I'm gonna simplify inside there with x squared minus 2x minus 3, and then we have x plus 1. Remember, when it's like this, you have to factorize. There's no other way. So here you're gonna factorize on the top, right? I open my two brackets. I should have x and then x. Factors of 3, that's gonna give me 2. It's 3 and 1. So I should have 3 as negative, so that I say negative 3 plus 1 will give me negative 2. Okay, all divided by x plus 1. Okay, remember, I'm simplifying it. That's why you are seeing it in yellow. I'm still simplifying. So now this will then cancel that, right? Then what are we left with? We're left with x minus 3. Okay, now that I'm done with simplification, it's now in the form axn, because there is a 1 here, there is a 1. So now I'm gonna apply the rule. When I'm applying the rule, it says if the exponent is 1, just take the number in front, which is 1. And then here it's a number. The derivative of a number is what? Of a constant is 0. So the answer is just 1. Okay, I hope you are getting it. I hope you got it correct, right? Let's look at the next one. Okay, so the next one here, we have this. Okay, I know that it's not related to what we are doing, right? It's not right, it's not expressed in this form. That is okay. I just wanted us to look at this. It's very quite interesting. So how do you find the derivative then? Okay, so you already have your f of x as square root of x, right? Now remember, you want it in this form, right? So you're gonna say f of x is equal to, remember the exponent is 1 there, so you're gonna say x to the exponent 1 goes on top, and then whatever was there goes on the bottom, like this. Okay, then to find the derivative, now when I'm applying the rule, I write it in white. To find the derivative, I just say 1 times half, 1 times half, right? And then I say x half minus 1. So what will be the derivative there? The derivative would be half x to the power of negative half. Okay, but now they want f prime prime x. So what does f prime prime x mean? It is the second derivative. It means once I'm done differentiating here, I must differentiate again. Okay, so to get f prime prime x, right, I'm gonna say this that I got, I'm gonna apply the rule again. So I'm gonna say half multiply by the exponent, right, which is negative half, and then I say x, and then I say the exponent minus 1. So what will be the answer? Half times that will be negative 1 over 4, and then I'll have x. The negative half minus 1, that will be negative 3 over 2. Then this would be f prime prime x. Okay, so I just found it quite interesting there to put. All right, then we go further, we do others. Now this one, I think we just saved the last two, and so this is a bit of a recap from those ones that we did before, right? So how would you solve this one? So remember, you want to put it in the form ax to the power n, right? So you're gonna have y is equals to 4 times x to the power of 1 over 3, right? The exponent is 1, then you divide by 3. This is to remove that radical sign there. Okay, what about this one here? That one there, it's 3x to the power 3 all squared, which means 3x to the power 3 times 3x to the power 3, right? So your y would be 4 times x to the power 1 over 3 plus 3 times 3 is 9, and then x to the power 3 times x to the power 3 bases are the same. We add the exponents, we get 6. Now that it's in this form, we can apply the rules. So our dy over dx would be 4 times 1 over 3, right? Whatever is here times the exponent, isn't it? Then you say x, then you say the exponent minus 1. Okay, then you say plus 9 multiplied by 6, which is whatever is here times the exponent, right? Then you say the exponent 6 minus 1. Okay, so your dy over dx would be what? 4 times that would be 4 over 3. Then you have x. 1 over 3 minus 1 would be negative 2 over 3. And then 9 times 6, 9, 18, 27, 36, 45, 54. Nice. So you're going to have 54 and then x to the power of 5, because 6 minus 1 is 5. Okay. Then if you want to leave it as with positive exponents, you're going to say this. Then remember, you're going to write 4 on top, write the denominator, and then this is going to join in the denominator and have a positive exponent. Okay, then you can say plus 54x to the power of 5. Right. By the way, now that we are comfortable with that, you must know that we don't actually end here. You can actually write now this as dy over dx is equals to 4 over 3. Now this that x to the power 2 over 3, you can write it as, you open your radical sign, then the base you're gonna write it inside. Remember, this is the exponent for x, so it's gonna be x there. Then remember, this is the root, it will be like that. Okay, so it will be like that. So for example, if I had 1 over 3, I can write it as, I open my root sign, I say x, the exponent is 1, and then the root will be 3, right? So it will be the cube root of x. So this one here, we can actually write it as, we open our root sign, we say x, and then the exponent will be 2, which is the numerator, and then the root will be 3. So that will be the cube root of that, and then plus 54x to the power of 5. So it means you are done. But it's fine, even if you end here, it's okay. All right, then the last one, right? The last one, before we then move on to I think in fact that was the last one. So the next questions we'll be looking at now, it will be application of calculus on the graphs, especially talking about tangents, right? Then after that we will talk about cubic functions, and then we move on to optimization. As you can see, calculus is not really a lot, but you have to practice a lot of questions for you to be ready for the exam. Okay, so this one I'm gonna leave it here for now. Just look at it, right? Just look at it, and on our next video we'll be talking about such. Thank you so much. Stay tuned.